What is going on, guys? Welcome back. In this video today, we're going to do a crash course on MLFlow, which is an open source AI engineering platform, or you could also say it's an MLOps toolkit, because it's all about monitoring, evaluating, analyzing, observing, debugging, and deploying models. So it's all about the MLOps side of things, and it operates in two worlds. One is the Gen AI world, the other one is the classic machine learning world. So MLFlow is a toolkit for both of these, and you can switch back and forth between the modes. We're going to cover both in this video today, and in both cases, we're talking about MLOps, AI ops, which means this is not the best beginner tutorial. You should know how to work with agents. You should know your way around, obviously Python, but also stuff like LangChain, the OpenAI package, or if you're just interested in the second part, PyTorch, Scikit-Learn, whatever you want to use. But this builds on top of that. Here we're talking about actually maintaining and having an overview over these systems. So if you like this video, let me know by hitting a like button and subscribing. And now let us get right into it. All right, so we're going to do a crash course on MLFlow today. This is the GitHub repository. As I said, it's an open source AI engineering platform. This is what they call themselves. I like to call them an MLOps toolkit because it's all about these things that are highlighted here: debug, evaluate, monitor, optimize, evaluation, prompt management, prompt optimization, AI gateway, observability. These are all buzzwords in MLOps and AI ops, and this is what MLFlow is about. So yeah, that's basically the GitHub repository. They also have a website, but I want to talk about the theory too much here. I want to get right into it and show you how it works. So for this, choose a directory on your system. In my case, it's going to be the tutorial directory, and here we're going to set up our project. Now, project setup is maybe a fancy way of saying just choose a directory and put the stuff that you need in there. In my case, I'm going to use UV as a package manager. You can do the same thing if you want to. Otherwise, you can just use pip. So pip or pip3 install the packages that you need. In my case, I'm going to say UV init to create a UV project. And then instead of pip install, I'm going to say UV add. I expect most of you guys to understand what I'm talking about because, as I said, this is not a beginner tutorial. MLFlow is something that you learn on top of the existing skills that you have, hopefully, in this field. So what we're going to obviously install is MLFlow itself. We're also going to use OpenAI and LangChain with OpenAI, not necessarily as part of the crash course, but just to showcase some examples here, to show you how to work with these things. We're also going to add Mistral AI, but other than that, we're going to add the packages as we go. The only exception is one more package that we need is for managing the API keys. We're going to need an OpenAI API key and whatever model you also want to use. On top of that, you should have an API key for that as well. How I'm going to do it, I'm going to have a .env file, and this .env file will contain an OpenAI underscore API underscore key. That's going to be my OpenAI key. And then I'm also going to add stuff like Mistral, API key, and so on. So whatever you want to have here as an environment variable, put it in the .env file. And then we're going to need the package called python-env to load this .env file, to load the content from this .env file into our Python script. So in my case now, I copied a .env file with my credentials into this directory. The other stuff is just the default stuff that UV creates when you create a new project. And what we want to do now is we want to start an instance of MLFlow to see what the environment looks like. And then what we're going to do is we're going to take existing code. We're going to look at a couple of code examples that already work, and we're going to see how easy it is to attach them to MLFlow and to send stuff to MLFlow for monitoring, logging, and so on. So first, we're going to run UV run in my case. Otherwise, if you're doing this globally, you can just run directly MLFlow server. And that is going to run the backend and also the front end that we need for MLFlow to work in the first place. So keep this open. You want to have one terminal open with MLFlow running, and that is the thing that we're going to connect to with Python or within Python. And we can also open it in the browser. So I can click on this link here, and we're going to be taken to the MLFlow dashboard. And right away, you can see at the top left, we have Gen AI and model training. These are the two different modes. In this video today, we're going to cover both of them if you're only interested in one of them. So if you, for example, only care about Scikit-Learn and PyTorch model ops, MLOps, then you will find timestamps in the description down below. You can jump immediately to the classic ML part. If you're only interested in Gen AI part, we're going to start with that. Then you can turn it off. If you're interested in both, just keep watching. So Gen AI means working with LLMs, working with agents, AI gateways, LLM gateways, LLMs that judge evaluations, and model training is hyperparameter tuning in Scikit-Learn or in PyTorch, model checkpointing, also having a model registry and using the models from there, versioning models. We're going to talk about all of this, but this is an important switch here. Gen AI versus model training is going to allow you to switch back and forth between these two worlds. Now, the next thing we're going to do is we're going to set up experiments. You don't need to do that, but it's just a nice way to group things. By default, everything lands in default. But for example, if I want to do some OpenAI prompts to play around with, I can say create OpenAI prompts. That is the name of my experiment. And in Python now, I can target this experiment, and every trace, every evaluation run, everything I do here on the side will be collected in OpenAI prompts. So to make this simpler, let's move our terminal with the server to a different screen or workspace so we don't have to see it. Don't close it, keep it open. That is the thing that is running here in the back. We're also going to, for now, move the browser to a different workspace. Now I'm going to open up the terminal again, navigate to tutorial again. To have some auto completion in NeoVim, I'm also going to activate the virtual environment. So venv bin activate. And then we can start with a basic code example. So let's delete the default code. Let's go full screen. And here now I have a prepared code example, very simple. If you don't understand what you're seeing here on the screen, if this is not obvious to you what's happening here, this is not the right video for you because you're lacking some fundamentals. This is a very basic prompt using the OpenAI package. So if you're confused by this, you shouldn't be watching this video because you should learn the basics first. But in general, this is how we're going to do it in this video. I'm going to copy paste code examples and we're going to enhance them with MLFlow to see how easy it is to take existing code and add this MLOps side of things on top. So what we have here, OpenAI package .env means loading the content from the .env file. That's basically just loading the API keys. And then we send a simple prompt to O4 Mini that says, what's the weather like in Seattle? Now, in this case, it's not going to return the weather because it doesn't have the tool, but we can just keep it like this. And the only thing I need to do now to add MLFlow on top is to import it, first of all. So import MLFlow. And to set a tracking link. So I need to say MLFlow set tracking URI, in my case now localhost port 5000. And optionally now I can also set an experiment. I can say MLFlow set experiment and target specifically the OpenAI prompts. Again, this one's optional. If we don't do that, we're going to keep everything in default. But the most important part is to actually auto log everything that has to do with OpenAI. So we need to say MLFlow.openai.autolog, and this is going to automatically trace everything we do here with the OpenAI package, which also means running a chat completion. That is all we need to do. So I can close this now and I can say UV run main py. If you're not using UV, you just say Python main py. And by doing this now, I'm sending a request to OpenAI. I'm getting a response. It's going to tell me it doesn't have a tool to give me the weather data, but that is a conversation, and this is going to be traced in our MLFlow. Actually, here it used some tool, or maybe it hallucinated something, but it gave me actually an answer, so that's also fine. And if I look now into the dashboard, if I go to my OpenAI prompts, I can go to traces, and we can see that something happened. I actually asked for the weather and I got a response. We can also see immediately that this took 617 tokens. 24 of these were input tokens. It took 5 seconds to execute. And if I go into this, we can see more details. We can see how exactly everything happened. In this case, not too fancy. We just had a system prompt, a message, and then the answer. I don't know if this is based in reality or if this is just a hallucination. Both possible, but we're not seeing the tool calls of OpenAI here directly. What's interesting is that this is very powerful for actual applications in production, because on the overview tab, I can do this for a bunch of different requests and I get aggregated statistics. So here I get percentiles, 99th percentile, 90th percentile, in this case, all the same because we only had a single trace. And if I have enough data, I can negotiate service level agreements with users, for example, based on these statistics. Because I know, for example, that the 99th percentile when it comes to latency in my system is 5 point something. And if I know that, I can guarantee and I have a certain calculable risk that I can talk with, that I can use in my conversations and negotiations. And in general, I can also see which requests use a lot of tokens, where can I maybe save costs. I also get the dollar dashboard here. So this is very, very useful if you set this up properly. Then we can take a look at the second example here. It's basically the same, just that we now have a tool that we can use, the get weather tool. It's always going to return the same fake information. We have still O4 Mini now with access to get weather. Now, one thing, bind tools just allows it to request a tool call. It doesn't actually execute it, so we're not going to see the answer. This is just a very, very small demo script. But essentially, the interesting part here again for MLFlow, how do I use this with LangChain? Now we're no longer using OpenAI, we're using LangChain. In this case, everything stays the same. We just say MLFlow.LangChain and then autolog. Same as with the OpenAI code, just that we use .LangChain. And with this now, I can say UV run main py. I'm not going to get a response. As I said, we're going to get probably just a tool call and then it's going to end. So there's no content here, as you can see, but in the trace, if I reload, we can see now I have two traces, and here I have the tool call, the assistant called the get weather tool in this call, city Seattle. Now, to also show you a third example, this is what it would look like with Mistral. I'm loading here the Mistral API key. Everything is just Mistral code, and here the only difference again is MLFlow Mistral Autolog. Here I actually have in my prepared code Mistral. Let's just keep OpenAI prompts, doesn't really matter. I know it's not OpenAI, but I'm gonna just keep it here in the same project. UV run main py, that's also not a problem. So here we get the answer as content, and if I go back into the traces, we can see we have a new request and response, also worked easily with Mistral. Yeah, so this is basic tracing. This is just taking a look at what's happening. We do get some metrics here that are interesting: token counts, cost, latency, just stuff to look at, stuff to keep track of, stuff to analyze and optimize maybe. But now let us move on to the second thing, which is evaluation. How do I evaluate LLM systems or agents? For this, let's go into main py, delete everything, start from scratch. And now let's say we have this simple setup here. We just have a basic function, ask agent. It just has the system prompt, you are a helpful assistant, answer questions concisely, and then whatever the question is, and then we get a response. The answer is the .content field. And I have a data set here, a very simple one. What is the capital of France? Paris. Who was the first person to build an airplane? Wright brothers. Who wrote Romeo and Juliet? William Shakespeare. So these are the answers that I'm expecting, and these are the questions. Now, how do we use MLFlow to automatically evaluate this dataset or evaluate this agent based on this dataset? First of all, of course, what we do is we start by importing MLFlow and doing the usual stuff like MLFlow.setTrackingURI localhost 5000, and then we can go and set the experiment to a different one. This time I'm going to actually choose a different one because we're now looking at a different use case. Let's call this evaluations. And now we're actually not going to do tracing, we're actually going to import additional stuff. So let me maybe move the MLFlow import down here, and we can say from MLFlow.GenAI import the scorer. This is a decorator that we can put on top of a function for scoring. And then also from MLFlow.GenAI.scorers, we can import guidelines and correctness. So we're going to use these two classes that are built in and the scorer decorator as well. And now basically the correctness scorer is just telling us if the answer is true. So if the agent responds with a very long message describing that the capital of France is Paris and the expected response is just Paris, the correctness will still fire true because the answer is the same. Even if you express it in 500 sentences, if your answer is that Paris is the correct answer, it is correct. Now, it's not concise, and maybe if you say that in German, it's not going to be fitting a guideline that expects it to be English. So we can define a guideline that this is actually English, and that would then be wrong. This would return a false. And we can also make a custom rule that says it cannot have more than 5 words. That would also not be correct in this case, or this would also not satisfy that scorer or satisfy that guideline. But the correctness is unaffected by this. So we're going to have a list of scorers that we can apply to the outputs of the model. For this, let us define a custom one. I'm going to call this one is concise. We're going to get the output, which is going to be a string, and this is going to return a Boolean. So it's either going to be true or false. Is it concise or is it not concise? Let's add a docstring here. Evaluate if response is concise. which means less than 5 words. And here then I'm gonna just say if length, or actually we need to split. So if length output.split, if we split and we get more than 5, then we're gonna return false. So actually maybe to make this easier, let's just return directly that this is less than or equal to 5. Then it's gonna be true, then it's actually concise, otherwise it's not. So to make this a scorer, all I have to do is I have to say add scorer. And then with this scorer now, I can say scorers is equal to, and I can say I want to have the correctness scorer. That's going to be just a default instantiation here. I want to use guidelines. Here, let's call this one is English. And the guidelines is going to be answer must be provided in English. And then we can also add our is concise. And that's basically the entire setup. The last thing that we need to do is we need to actually apply this. We need to actually run the evaluation. So we're going to say mlflow.genai.evaluate with a lowercase e. We're going to say the data is equal to the eval dataset. The predict function is equal to the ask agent. And the scorers are equal to the scorers that we have. That is basically how we do a simple evaluation. We just have the model. This is our inference function, our prediction function. This is our data set. You can extend this to be as long as you want. This is our custom metric. This is a default, and this is a guideline that we just express in language. Now I noticed that we have 3 little mistakes here before we can actually run this. One is that I mistyped MLFlow down here, so MLFlow, not MFlow. Second is this parameter needs to be called outputs, not just output. So outputs is important here as a keyword. Because it's passed as a keyword argument. And the other thing is, of course, we need to instantiate the OpenAI client. So client is equal to OpenAI needs to happen here. Otherwise, we cannot use it in this function. So once this is done, go and run the main PY file. And this is going to run the evaluation now in the terminal. As you can see, evaluating 0 out of 3. And once this is done, it's also going to give you the link where you can see the results. So we can actually click on this here. This will open in the browser. We can see we have our evaluation run here, and we can see the individual questions, the individual rows of the data set. And when I go to the right, we can see that correctness always passed, is English always passed, and is concise never passed because it was never concise. If we want to see why that is the case, we can go to this question, for example, who wrote Romeo and Juliet? And the answer is Romeo and Juliet was written by William Shakespeare, which is of course not a very concise way to answer because you could have also answered just the name. So this is how we can easily run evaluations in MLFlow. We just have to specify the metrics that we're interested in, correctness, conciseness, English, whatever you want to define. If you can express it in language or in Python code, you can use it as a scorer and automatically evaluate your agents, your models using MLFlow. If I may for a second, I would like to plug myself in as the sponsor of my own video. If you go to my website, neural9.com, you will find a tab services and a tab tutoring. Here you can hire me for all sorts of stuff like data science, machine learning, web development. If you need help with something in a project, here you can book me for one-on-one tutoring if you want me to teach you personally something that you don't understand. If you like my teaching style, on both pages at the bottom, you can contact me via mail and also via LinkedIn. Just wanted to let you know about this. The next thing I want to show you here is how to work with prompt templates. We can go down here to prompts, or maybe let's go and do that in a separate experiment. Let's say prompting is the experiment name, create this. And here we're going to go to the prompts and we can create a new prompt. So just create it, give it a name like my prompt or something. And then we can use, as you can see here, variables can be wrapped into double curly brackets. So we could type now, summarize the following text using exactly, and here we can introduce now a variable, num underscore bullet underscore points into exactly that many concise bullet points. And we can also use a second variable here for the actual text. Let's say summary content. That is my prompt. I can create this and now it's an object here in MLFlow. So I can actually use this. Also interesting, I can create a new version. I can edit this prompt and this turns it into a new version. So I can not just edit it and keep it. I can create a new version of this prompt. So for example, I could maybe remove the concise here if I want to. Then this would create a new version. And I can see now version 1, version 2. I can also compare them in a diff view. So then you can see actually, okay, what did change here. And you can see concise is added here in this case. If I actually want to see the div view, I can go to the text mode here, and you can see this is green depending on the side that I'm looking at. Here it would be red if I take the old one on the left side and the new one on the right side. But that is now my prompt, and I can use that in Python by just providing the summary content and the number of bullet points. Now, how do we use this in Python then? In this case, I don't have any MLFlow stuff implemented here yet. I have a run prompt function. This just sends a prompt to O4Mini and gives me the response. I have a very large text here from Wikipedia, which is the Python page. And now what I can do is I can just use the prompt template here in content. For this, of course, I need to pass the parameters first. Let's say we have number of bullet points here, and also we have the summary content. And now to get the prompt and fill it, I can say prompt is equal to mlflow.genai.loadPrompt. And now here the URI is prompts, and then colon slash the name we gave it. So in my case, it was my prompt. And then the version number after a slash. So 1 would be with concise, 2 would be without concise. Let's go with 2. That is now my prompt loaded in Python. And now to actually fill the stuff in, I can say prompt.format, and just number of bullet points is equal to number of bullet points, and then summary content is equal to summary content. Now, if I also want to enable tracing for this function, I can say @mlflow.trace. And that is all we have to do to use this prompt. Now let's execute this down here. Let's say run prompt, also print the result. Run prompt with number of bullet points is equal to 3, and summary content is equal to the text that we have here from Wikipedia. And let's see if this works. So there you go. I got the response from the LLM. Python is a high-level general purpose language. You can see that these bullet points are pretty long. This is also probably because we're using the second version where we didn't have concise bullet points. So maybe I will get shorter bullet points if I actually use version 1. Let's see if that's the case. And no, the bullet points are not really that much more concise, but we could of course extend the prompt to say something like don't allow the bullet points to be more than 20 characters or something. That could be version 3 in this case. So of course we can also see all of this in the traces, but since we didn't provide the experiment here, we have to look in the default. If I go to traces, you can see what we pass here is number bullet points 3, summary content, and this is the input, that is the output. We basically applied our prompt template. Next up, let me show you how we can set up an LLM gateway. So how we can handle all the LLM requests here via MLFlow. For this, we can go down here to AI gateway and create an endpoint. However, before I do this directly, I first want to set up connections to models. I actually want to be able to ping the OpenAI API and Mistral AI API from MLFlow. So I'm going to go to settings. I'm going to go to LLM connections. And here now I'm going to create my API keys. I'm going to look for OpenAI. I'm going to call this OpenAI-key, and I'm going to provide my API key. So I can copy paste it here, create API key. That is my OpenAI credential. And then I can go and also look for Mistral AI and call this Mistral key. And I can also just copy paste my Mistral key, create API key. Now I have these two LLM connections set up. And when I go back to AI gateway endpoints, I can now create a new gateway endpoint. Let's call this my endpoint. That's fine. Enable usage tracking. And here I can choose now the OpenAI model again. Let's go with GPT-5.5. And for this, I'm going to use an existing API key, which is going to be my OpenAI key. So just take that, create. And now I have my endpoint here with a primary model, which is OpenAI's GPT-5.5. And we can do a bunch of things here. The most basic thing that we can do is we can just use this now as an endpoint to send our requests through, so we don't have to actually ping the OpenAI API directly. Everything goes through our gateway here. And by doing that, we can handle certain things. For example, I can do load balancing with different models. I can add a second model here to say 70% of the traffic has to go to OpenAI, 30% to Mistral. Now, I don't really want to do this here, but what I want to do is I want to add a fallback model. So what happens if this model fails, if it doesn't respond? I want to use a second model, which is going to be the Mistral model. So here I say Mistral will be my fallback. I will use an existing API key. Let's go with something like Mistral small latest maybe, or let's go with large latest. That's also fine. And use an existing API key, Mistral key. Save changes. And now in Python, I can treat this endpoint as if it was an ordinary OpenAI endpoint. So here we have the requests package in Python, just sending a post request to localhost 5000, gateway, the name of the endpoint, my endpoint, MLFlow invocations, and here I'm just sending a hello. So I can write this, I can run this. Maybe let me clear the screen so you can see this, uv run main py. And that will now send a request to the gateway, which will send it to OpenAI, and it will tell me, hello, how can I help you today? And you can see the model that responded here was GPT-5.5. Now, let's say that I artificially engineer a problem. Maybe I can go here to my connections and enter a wrong API key. So maybe we can go here and I could just delete a couple of characters here, just save this. It's going to be considered true. It's not tested. And now I can try to ping the same endpoint. I think the key should be still used from there. So let's try to do this now. This should fail and then redirect me to Mistral. As you can see, Mistral large latest answered, the fallback model. Now for the next example, I want to show you how we can deploy an agent as an agent server. So basically it's a fast API endpoint that we can send requests to. This is also quite easily doable with MLFlow. For that, we're going to start with some imports from mlflow.genai.agentserver. I want to import the invoke decorator here. Then from mlflow.types.responses, we want to say responses, agent request, responses, agent response. And we already have a system prompt here. If you saw it, it's basically you provide help with math problems, explain your reasoning, and include examples. Then we initialize here using LangChain a simple 4.0 mini instance. And now we're going to have a function that is going to give us a non-streaming response. And then we're going to take this function and wrap it in a fast API application using MLFlow. So I'm going to say here async def non-streaming. And this is going to take a request as parameter, which is going to be a responses agent request, and it's going to return a responses agent response. Then we're going to just say that we have the system message here, and in addition to that, we're going to add everything from the request. So from the request input, we're going to do a model dump on the individual objects, and then we're going to invoke the model asynchronously. That is going to give us the results. And finally, we're going to return an instance of the responses agent response. This requires an ID, a unique ID message, UUID, hex version of that. Then we have the type message, role assistant, and the content of this response will be sent here. That is just basically the function. Important to actually make this work, we need to decorate it with invoke like this. And in a separate file now that we're going to call start server, we're going to actually take this and run this as a fast API application. So let's rename this here to not be main py, but agent py. And then I will say start server py is a new script. And here we're going to say import agent, import MLFlow, then from mlflow.genai.agentserver, import the agent server, and also the setup MLFlow Git-based version tracking. And then we just have to say MLFlow set tracking URI, same as before. We're just going to go with a localhost and then port 5000. And then we're going to say agent server is equal to agent server. Let's pass responses agent here, and the application is going to be agent server.app. Next, we're going to say setup MLFlow Git-based version tracking. Call this is a function, and then just agent server.run, and the app import string is going to be start server app. And of course, in production, you want to actually, if you actually deploy this to a server in production, you want to make sure that you're running this with UVcorn or something. But for the dev server, that's quite simple. Let's see if I made any mistakes. Just say uv run start server py. Now we have this running on localhost port 8000. And to give it a very quick test, we can just send a post request using curl. So we're just sending to this endpoint here, two invocations, the question, what is the 14th Fibonacci number? And let's see if we get anything back. And there you go. The response tells us that the number is, it explains us first of all what the series is, and then tells us the number is 377. So as you can see, this is how you can easily turn a model that you already have into a fast API endpoint, into an API, basically using MLFlow. So at this point, we're going to switch to the other paradigm. Now we talked about Gen AI. We looked at evaluation, prompt templates, tracing, gateways, and everything. Now we're going to model training. Here we're going to the classical ML side of things. We're going to go to experiments and create an experiment called Classic ML, and we're going to see how to use MLFlow in this context. So for the first example, I'm going to install, in addition to the packages that we already have, Scikit-Learn. And then we're going to take a look at a very, very simple example. We just have Scikit-Learn datasets. We have model selection, we have linear model, and here we load the iris dataset. We do a basic train test split, 20% testing, 80% training. And we have a logistic regression model that we fit onto the data. Nothing fancy, but maybe we want to keep track of what is happening. So this can easily be done as well. We can just say import MLFlow, and same as before, MLFlow set tracking. URI is going to be HTTP localhost port 5000. Also MLFlow set experiment, this time classic ML, and not a surprise, MLFlow.sklearn.autolog again accomplishes the task. So let's see what happens when I run this. UV run main py. There you go. This completes. And if I go now back to my experiments, classic ML, we can see that there was a run. And if I go into it, we get a bunch of metrics. I see precision score, recall score, F1 score, accuracy score, log loss, area under the curve, training score overall, which is basically just a score function. I think that's the same as the accuracy score in this case, in the case of classification. And what's also cool, in addition to the model metrics, I can also go to models here, and I can see that I have the model as an artifact here. I have the pickle files and the YAML files and everything, and I can register it into my model registry. So I can say register model, then I can create a new model here. Let's call this one log rec model, register, and now this model exists in my model registry and can be used by Python scripts. Also, you can see it has a version, so we can also version this model. And when I look into the specifics here, we can see the input shape and the output shape. Now, if you want to use this, you can basically copy the URL here. We do have to change a bunch of things, but basically copy the URL of this version page, go back into Python, open up main py, let's delete all of this, and then let's say model URI is equal to, store this here. And we do have to change a couple of things. First of all, remove the leading slash, add a colon after models, then slash logrec is the name, and we also get rid of the versions here. So we just say /1. That is the model URI. And then how do we actually use this? We say import MLFlow. I'm also going to import pandas to have some sample data, pandas as PD. We're going to set the tracking URI once again to be localhost 5000. And then we can say model is equal to, and I should define this up here, model URI. Model is going to be equal to MLFlow.pyfunc load model, and then the model URI. That is going to take it from the model registry, and the rest is basically just going to be a sample data frame, and then we're going to do predictions and get the predictions printed. So UV run main py, downloading artifacts, and it gives me 0 and 2. These are the classifications, the classes actually. So this is how we can train models, how we can trace them using MLFlow, even if we're just doing basic scikit-learn stuff, and then how we can take an artifact, add it to the model registry, and reuse it easily. Now, then I also want to show you briefly an example of hyperparameter tuning. For this, we're going to add a package called optuna. We're not going to focus too much on it here, but I want to show you an example, which I'm not going to code from scratch. We still have here a basic scikit-learn example, random forest regressor. We have the California housing dataset. We do a basic train test split again. And what we do now here is we define an objective and we define what a run looks like. So we have here max depth, n estimators, max features. These are all hyperparameters for a random forest classifier. We define a range that we want to have here. And basically with optuna, we're choosing random values in this range for our hyperparameter tuning. So it's a randomized search for the optimal parameters. And what we do here as well is we log everything, and we start the run using MLFlow. In this case here, we have 30 trials that we run through. 30 times we generate different random forest class regressors in this case. that make predictions that we evaluate. We log all the metrics, we print the best error and also the best run. But instead of just printing this in the command line, we're also going to be able to see this in MLFlow. So we can run this. By the way, you will find all these scripts here on my GitHub. You will find a link to them in the description down below. So if you just want to copy paste them, play around with them, you can feel free to do that. I just don't want to waste too much time here typing everything word by word. But there you go. You can see it starts now, trial 0, finished with value and the respective parameters that were chosen. So the really important thing here is not the optuna stuff, but how we deal with MLFlow. We start the run, we make sure that the run has a proper name, and important, every time you want to log a metric or you want to save a model, you call MLFlow log metrics. You give it a name, you give you log the error or the value in general, depending on what the metric is. And also with log model, you have to use Scikit-Learn or PyTorch or whatever, and you have to give it a name. But that's basically it. You want to log metrics, you call log metrics. You want to log models, you call the respective submodule log models, and also the same with the parameters. If you want to keep track of something, you just call the respective log function, and everything else is not MLFlow. The whole fine-tuning process is actually happening with Optuna, but MLFlow makes it super easy to track everything and to log everything. And by the way, while this is running, you can take a look at the trial. So right now we're at trial 18, so I can just click on this here, and this will open the trial that just happened here in MLFlow. I can go back to runs here, and I can uncollapse this and see all the trials that we had. And I can see how long it took. I can also add a column here. So I can click on columns and add the error column, which is probably the thing I'm most interested in, and then sort by it in ascending order. So that right now, trial 2 seems to be the most promising one, and I can already access the artifact. I can already go to the model and register it in my model registry if I want to. And I can also see what the parameters are of this model that is up until this point the most promising one. We have a max depth of 24, max features of 36%, and we have 250 estimators, so decision trees. So now we can see everything finished. I can go back to the experiment and see that finally the best model that we have here, the best run, was actually trial 2. So I can go to this one, take it, register it, and this is how we can do hyperparameter tuning. I can also enable the other columns here. Maybe I care more about precision than error, and then I can, in this case, I'm not logging precision, so it doesn't make a lot of sense. But theoretically, I could log precision, and I could also sort based on that, figure out what the best model is in this case, get it, register it, version it, whatever. And now finally, the last thing I want to show you is how we can use MLFlow with PyTorch, not in this case for hyperparameter tuning, but just for tracking the progress, seeing how the losses evolve over the epochs. So for those of you who know PyTorch, you can see that all of this is very, very basic PyTorch code. Nothing here is too fancy or new. We just have the fashion MNIST dataset that we're loading. We're creating a data loader. We have a simple feed-forward neural network. We have a training loop, a validation loop, and that's basically it. The only thing that is new here is obviously the MLFlow stuff. So we have the same stuff as always, set tracking URI, set experiment. Here I called this deep learning experiment, so we need to create this one. Here I'm also enabling now system metrics logging, which makes sense because oftentimes when we do deep learning, we want to keep track of the RAM usage, disk usage, or CPU usage, whatever, GPU usage. So that is useful here as well. And then what you're going to see across this script, first of all, we have start run here again, but then we have log parameters. We have log metrics, so we keep track of the training loss, training accuracy, validation loss, validation accuracy. And here you can also see how we can do the checkpointing. We can just say PyTorch, so mlflow.pytorch.log model, same as scikit-learn.log model. And here we can keep track of the individual models per epoch. So that's quite simple. Of course, to run this, you need to actually install using uv-add or pip install Torch and Torch Vision for PyTorch and for the dataset. And once you have this, you can just say uv run main py, and we're going to see in MLFlow that we get very useful graphs for how the training went. Okay, so here I get the issue that I don't have psutil installed. Maybe I should have this as a Linux tool, but now I'm gonna just say uv-add psutil to keep it simple. Let's rerun this. So here you can see it started monitoring my system metrics. I don't have a GPU on this laptop. And now we have epoch 1 out of 5. with a training loss of 1.7. Now it's going to do this for 5 epochs. And in MLFlow, we're going to see a very nice visualization of that. So now we have 5 epochs done, as you can see. So let's go back into our MLFlow here. Let's go to deep learning experiment. Actually, I didn't create this one, so it created it automatically. Didn't know that this happens. And here now you can see 1 minute ago, we had this run. This is the text version, but we can go to model metrics, and here we're going to see nice graphs of what happened. The batch accuracy over time increased a lot in the beginning, then it increases slower. The loss went down, the train accuracy went up, the validation accuracy went up, the validation loss went down. This is a very good sign, and we should keep training here. Epochs, 5 epochs are not enough. If you see something like the training loss going down while the validation loss is going up, you're probably overfitting. This is something that you can easily, or not probably, you're most likely overfitting. So this is something you can easily see here. You can also go to system metrics to see what is happening here with the CPU utilization. Obviously high, then it makes a break or takes a break. Then we have the next epoch, break, next epoch. So that's understandable. Disk usage goes up over time. We also see what's happening here on the network graph, so to say. So that's quite useful to monitor the whole thing. And of course, we have the models. Every epoch created a checkpoint model. We also have the final model. So if for some reason I think that epoch 4 had the best model, I can go to checkpoint 3, again, throw this into the model registry, or just take a look at the metrics for this specific run. So yeah, that's basically what MLFlow is for. I would call it an MLOps toolkit. They call it an AI engineering platform. Both is fine. You have Gen AI features, you have model training, but at the end of the day, it's all about monitoring, logging, comparing, analyzing, visualizing, keeping track of what's happening, which is a very, very important thing to do in production. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a services tab and a tutoring tab. There you can contact me if you need help with a project, if you need a freelancer, consultant, if you need someone to work on a project with you. You can contact me at the bottom of these pages via LinkedIn or email. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.